Hello, everybody. Thanks for joining us in another Wednesday e-learning session with Peerless. This week's event is going to be industrial hose systems and the importance of applying them correctly and proper hose assembly. So with that, we are going to turn our cameras off and get going. All right, once again, today's topic is industrial hose systems. Joining us, we have a good geography, good industries, and this is, I believe, the first time I've added Manitoba to the geography. So someone up from Winnipeg. Thanks for joining us, everybody. Again, Peerless started in 1914 as a primary mill supply at downtown Buffalo, operating primarily from a catalog. We've certainly had to evolve over time to become a trusted source for process components. We do operate under three main segments. The process group is really our MRO type services to the chemical, pharmaceutical, really the plant environment. Within this team is where our hose fabrication and testing group lives. We do have a assembly test area, and we do build hoses every day, hose assemblies. The Procore team, this is where we focus on the equipment builders and very challenging usually projects that require some higher level specification. And finally, our high temp fabrication group. We work with scientific surfaces, laboratory casework, and high temperature insulation. So again, today's session is sponsored here totally by Peerless. Austin Smith is going to be presenting. He is one of our application engineers. He's been with us for 5.5 years. He is a Clarkson Mechanical Engineering graduate, and he spends a great deal of his time specifying hose assemblies. So the other side of it, you see the regular players, Dan Morgan, and it should be said that he is also a Clarkson Mechanical Engineering graduate. We have Greg Barrell, who will be taking a part in this today, as well as me, Kevin Renaud. So in the spirit of Halloween, the upcoming season here, you notice Austin's flow there. He's got quite the hair, and I'm a little jealous, naturally. But he uses it to good use. This is our picture from last Halloween. He chose to come as Shaggy from Scooby-Doo. And it's a good thing he did, because if not for him and those meddling kids, this guy probably would have gotten away with it. So before I move on, you may be wondering who this guy is. And there he is. Dan Morgan is an oddly spooky ghost. So Dan, I couldn't resist. Naturally, you're staying hydrated, so nice work. So with that, I am going to pass it to you, Dan.
Thanks. It was really hard to get work done that day without any arms, but I managed somehow. So, okay, for now, I'm just going to go through a couple of things, a couple of housekeeping items, introduce you a little bit to the interface that you are seeing in front of you right now. So you're looking at my screen right now, and just to give you a clue on some of these buttons. This orange button is used to collapse this control panel if you want to get it out of your way. You can toggle in and out of full screen mode right here. If you're having any issues with audio, you may not be able to hear me right now, so I'm not sure how useful that'll be, but here's where you can control your audio settings. And most importantly, and where we want you to focus on most today, is this questions panel right here. So if you want, you can expand this panel. It'll allow you to type out a question. And then part of what I'll be doing today is keeping an eye on all those questions that you guys are sending in. And then finding moments during the presentation to get those questions asked in front of the group and get you answers that you need if you want clarification on something that Austin's talking about, or maybe something that's application specific to you. We want you to submit those questions, and we'll get you some answers. So with that said, I'm going to hand this over to Austin quick, who will be driving the presentation and doing most of the speaking. So when he pulls up the presentation, I'll just, before he dives into it, I'll give you a quick run through of the agenda. So Austin, if you want to, there you go, perfect. So yeah, to give you guys an overview of what you'll be listening to and what we'll be talking about today. Greg Barrell is with us. He's going to walk through just a couple of quick slides and really portray that message we're trying to send of how critical an industrial hose system is, and some of the potentials and consequences that could happen if a failure were to occur. Then Austin's going to walk through the basics of what makes up a hose system, so the materials and the components that all go into it. Then we'll dive into a lot of the criteria and all the considerations that need to be made in order to properly specify a hose and a hose system to suit your application. He'll walk us through the steps that go into actually fabricating and making a hose assembly. And along with that, we'll touch on some of the important verification steps in that process, such as the crimp measurement and pressure testing. We'll also talk about some of the important quality considerations you might want to make, including, tagging, certification, lot tracking, just to ensure, you're getting a quality product that's going to have longevity for the application you're working with. And then we'll just touch on some procedures and considerations you might want to make for handling and storage to, again, ensure longevity and proper, adequacy of your hose assembly. So with all that said, Greg is now going to take us away with a little bit here. So Greg, good to go?
Yeah, thanks, Dan. Yeah, so I just want to get into a few of the hose failures here. I was on site at an area chemical plant, and you can see the picture here. And this hose actually failed right when I was on site. When I was on site, the hose ripped out of the fitting. It actually made an incredible loud booming noise. But what happened was operators had to scramble to mitigate this particular situation. Luckily, no one was injured and the spill was contained. But I do want to make a point with this hose failure. You'll see a metal hose there that's holding the hose together. That's actually called a whip check. Without that whip check, there was a potential for that hose to fly around, and that would have been even more difficult to contain the spill and reduce injury. So, we gave a lot of credit to the plant just for having that piece of preventative maintenance in place to prevent any other bigger catastrophe. So here's another example of a hose failure in a chemical plant that could have been avoided with proper preventative maintenance. And then lastly, here is a video that shows another example of a hose failure and the consequences with a failure. And I just want to point out that this is not a real person in the video. It's a mannequin, but it just wanted to point that out. And as you can see, by not having the hose properly installed, what can happen in this case, and really having a human injury. So I want to pass this along to Austin Smith, again, our senior applications engineer, where he's going to dive into all the aspects of making a secure and safe hose system.
All right, thanks, Greg. So to start off things here, we're gonna back it up a little bit, really get you an idea of what really is hose. Much like valves or instrumentation, hose is a purpose-built product. It's designed and built specifically for an application and or an industry that it's going to be seen. Some common examples you have listed here, obviously chemical, food and beverage, steam. But in the world of hose, there are 5 major categories of hose. Industrial hose, which we'll be talking about today. But there are also other types: corrugated metal hose, fluoropolymer or Teflon type hose, composite hose, and hydraulic hoses, which I'm sure we'll have a little more in-depth webinars about those in the future. But for now, we're going to just stick to industrial hose. But on the topic of hose in general, here's some common manufacturers, some of the more popular ones that either deal with rubber industrial hose or plastic industrial hose, hydraulics, metal hose, ducting, some a little bit of each. They get into some of all the categories, but this is a small number of manufacturers of who's actually out there. So what is hose? So NAHAD, which is the National Association for Hose and Accessories Distribution, they define it as a reinforced flexible conduit used to move materials from one point to another or to transmit energy. It is flexible to accommodate motion, alignment, vibration, thermal expansion and contraction, portability, ease of routing, and ease of installation. So it's a nice definition, but in reality, what does that actually mean? So in terms of industrial hose, an industrial hose is normally made up of in some grade of rubber or plastic with a reinforcement that helps to handle pressure and carry pressure. These are some of the common categories we see with industrial hose. Air multi-purpose, acid and chemical, food and beverage. If you look at any one of these categories, between different hoses in that category, you'll see a lot of similarities between, say, for example, material handling hoses. You'll see a lot of them with an abrasion-resistant tube, an abrasion-resistant cover, but they might have some slight design changes based on a specific application. But if you're going to look between these different categories, that's when you'll really see some major design differences. So dig in a little bit more into what industrial hose really is actually made up of. We'll start from the inside, where we have the tube, and the tube is what is going to be in contact with whatever this hose is going to be conveying. In the world of industrial hose, it's commonly made of different blends of rubber or plastic or fluoropolymers, just in the most basic sense of those terms. As you move outward, you come to the reinforcement, which you can see in this picture down here. Is the white is the tube, the darker material is the reinforcement, and that's built into the body of the hose, as you can see. And the purpose of the reinforcement is to allow the hose to withstand internal pressures or potentially even vacuums, any external forces, or even a combination of all of those. And that's also in the most general terms. Typically you have braided or spiraled textiles, a helix, or some sort of wire going through there. And then finally, we have the hose cover. That's the outermost element. The prime function of the cover is to protect the reinforcement and the tube from external damage from the environment. Once again, generally made of rubber and plastic, but they'll be made of different blends or grades depending on what the cover needs to protect against, whether it's need protection against oils, abrasion, sunlight, anything like that. So assuming an industrial hose is going to be right for your application, why would you want to choose an industrial hose as compared to the other styles of hose that we mentioned, such as fluoropolymer, metal, composite? Well, with industrial hose, assuming, like I said, it's right for your application, tend to get increased flexibility out of industrial hose. The way this hose is made, you're also able to get much longer continuous lengths than you would in other styles of hose. For example, typically metal hoses are provided in bulk lengths of 100 feet, but with some air and multi-purpose hoses, you can get those continuous lengths up to almost 500, 600 feet. That's just a product of the way the hose is manufactured. On that topic as well, you can get much larger bore sizes with industrial hoses. You do see some hoses get up into the 6 to 8 inch inside diameter range, but there are some available even larger than that for very specialized applications. And industrial hose, you can use a wide variety of types and materials of end fittings. as long as it has a shank on the end of it that can be inserted into a hose and attached. For the most part, you can use it with an industrial hose. So going on what the title of this webinar is about, what is an industrial hose system? In the most basic terms, a hose system is made up of 3 components, one of which being the hose, the other is the end fitting, and then we need an attachment method to create a secure connection between those 2. Over here on the right-hand side, we have a little cutaway showing how these 3 pieces interact. The green is the hose. You see the fitting on the inside with the serrations of the hose shank. And in this case, we're using a crimp ferrule, which compresses down to help the hose grip onto those serrations, but also provides another level of fitting retention with a interlock into the hose fitting. So, well, you know what makes up a hose system. How do we know what hose, what fittings, and what attachment methods are going to be used and going to be needed? And to get that information, we use the acronym STAMPED. This acronym helps us to gather the information that's required to provide a quality hose assembly that we know is going to work for your application. There are many different forms out there. Here's just an example of one of them to gather all the information that's helpful and, as a matter of fact, required to spec out a hose assembly. But for this, we're going to just briefly dig into each of these categories and really dig into what we really mean by size, temperature, application, media, pressure, ends, and delivery. So the S stands for size, and the size of the hose refers to both the inside diameter and the length. And now for hose, it's important to note that it is specified by the inside diameter of the hose, not like metal tube, which is spec'd by the OD. And unlike pipe, the inside diameter size is the actual size of the hose. It is not a nominal reference. A 3-inch hose will have a 3-inch inside diameter. Second to consider is the length. Probably even more than 95% of the time we're looking at hose applications, a customer is going to be referring to the overall length of an assembly. And an overall length is measured most of the time from, as you can see in the chart here, from end of one fitting to the end of the other fitting. But it is always a good idea and a best practice is if you're describing the length of a hose assembly to describe how you're measuring said assembly. Say, for example, we had a cam and groove fitting or any other fitting that has a seat in it. The overall length as a standard is measured to the seat of the fitting as opposed to the end of the fitting. So it's, as I mentioned, it's a good idea either way to describe how you're referring to that overall length. The second type of length is live length, and that just refers to the usable, flexible amount of hose that is in an assembly. And where live length really gets important is when flexibility and hose routing is of the utmost importance. As you decrease live length, your hose assembly is going to get a lot less flexible. You're not going to be able to bend it to certain offsets if it's too short without causing damage to the hose. So if you have an application where you need to have an exact configuration of the bend, it's usually a good idea to start with calculating what type of live length is needed. And on the topic of length, if you're in an application where the length is of most importance, You want to call out tolerance. Over here on the chart on the top right, we have NAHAD's standard hose tolerance that they give for industrial hoses, which, as you can see, is based on both inside diameter of the hose as well as the overall length. But it's also important to note that tighter tolerances are sometimes possible from these if required, but that does take extra labor during the assembly process, which will lead to increased costs. And while tighter tolerances are sometimes possible, just based on the way that hoses are constructed, sometimes an exact length, not all tolerances might be possible. So very important to consider if length is important. T is for temperature, and this refers to the temperature of both the whatever material is going to be conveyed through the hose, as well as environmental conditions that this hose may see. Usually we're looking at whatever maximum temperature in assembly is going to be seen, but it's also important to know if you're dealing with low temperatures, whatever the minimum temperature that you could see. At low temperatures, hoses are, especially industrial hoses, are going to get stiff, brittle. They might not perform like they were designed. And obviously the same thing goes at the maximum, that they're not going to perform as designed. And as you can see down the bottom of the slide, when you have increased temperatures, the rated working pressures of the hose and therefore your hose assembly are going to decrease. So if, say, you have a 300 psi hose and you're operating at 250 degrees Fahrenheit, that 300 psi hose is no longer rated at 300 psi. You're only going to be rated at 150 psi. Very important to take into consideration any temperature extremes, as well as knowing as if the temperature extremes are going to be continuous or intermittent. In the case of chemical hoses, some of them can be cleaned using steam, even though the hoses themselves are not rated for steam. For a short period of cleaning with open end, they can be exposed, but it is never a good idea to use a hose either above or below its maximum or minimum rated temperature. Next, we'll move on to the A, which is for application. And this is a very general category. Really, this is pretty much a catch-all of how is this hose going to be used, and tell us as much about how this hose is going to be used as you possibly can. There's some common conditions that we see, or if a specific bend radius or flexibility is required. It's going to be used indoors or outdoors. And also, if there's a hose currently being used that is working for the application, it's as simple as asking what is being used now. But some other categories that may be considered here is potential for exterior abrasion. If there's going to be any exposure to ozone, UV light, salt water, static electricity going to be an issue. Is there vibrations? List goes on and on and on. I could sit here for probably another hour talking about all the possibilities, but this is really why it's so important just to tell us as much as you can about how this hose is going to be used. So as an example here, we have a short video from a customer that was having a problem with continuous hose failures. They could not figure out why they kept on having hoses fail. You can see here, this is the cover splitting right by the end fitting. So they sent us a picture of a video of how the hose is going to be used. And as we watch it here, we can see it moving back and forth, back and forth. So when we received this video and watched it, it pointed us right to two issues that would have been helpful from the beginning to have known. The first is the description of how the hose is moving back and forth like that. You can see there's movement of the end fitting in two different planes. And what happens there is the hose begins to twist, which is not good for any type of hose. You don't want to have any twisting or torsional forces. But in addition to that, we also have other hoses rubbing up against it, which we were not aware of at the time before this video was sent. So from there, we were able to supply a solution of a live hose swivel here at the connection point, as well as providing hoses with a hard plastic abrasion resistant covering, so that when they would rub together, there would be very minimal erosion. We get a much longer lifespan out of these assemblies. So that leads us to M for the media or the material, which is whatever is going to be going through the hose. This is important to ensure compatibility between this media and also the material of the tube of the hose. In the case of say a chemical hose, we're going to want to know the chemical name as well as the concentration. An SDS sheet never hurts either. To just give us, just like the application, try to give us as much information as possible. As well as if there's any special requirements, say for a food and beverage hose, if it's a food product going through the hose, are you going to need the tube to have a FDA or 3A rating? If there's solids going through the hose, description of the solid as well as the size. Depending on what's going through the hose, you could have the potential for buildup of static electricity, which is pretty common with materials, powders, multi-phase media. Say with steam, if you have gaseous steam as well as condensate going through the hose at the same time, there's a potential for static buildup. And also, if you can give us information about flow rates or velocities, that's helpful to know, as many hoses have limits to the velocity of media that they're able to travel through them. Next, come on to pressure. This is going to be referring to the process pressure or the normal operating pressure that this hose is going to be seeing. But we're also going to want to know if there's a potential for any pressure surges, any type of pressure spike or surge that goes above the assembly's max working pressure is definitely going to, if it doesn't cause a failure, it's going to greatly shorten the lifespan of the hose. So very important to know there, especially as if this hose is going to be needing to handle any type of vacuum. Not all hoses are built equally. Not all hoses are going to be able to handle a vacuum. We're going to need to pull a vacuum. A metal helical wire going through the hose is going to help provide support. It's really allow the hose to hold its shape when a vacuum is drawn. As we touched on the temperature slide, as temperature increases, the pressure rating of the assembly is going to decrease. We have a slightly different looking chart here, but shows a derating factor at different temperatures for different hoses. So once again, if you're going to have a 200 psi rated chemical hose at 200 degrees Fahrenheit, you're going to want to be careful, as it's not going to be even rated to 100 psi. So very something to definitely take into consideration with elevated temperatures. And another important note about pressure rating is that the pressure rating of a hose assembly is not necessarily the pressure rating of the bulk hose being used. We've seen hoses that can be rated to 300, 400 psi, but standard cam and groove fittings are normally rated to about 250 psi. So if you're putting 250 psi rated fittings on a 300 psi rated hose, that assembly is not rated to 300 psi. It's rated to 250 psi. So very, very important to note that you take into consideration all the components of the hose system when determining a pressure rating. E leads us to the end fittings. Like I mentioned before, there's many different styles available, but the most common that we see are threaded, flanged, cam and groove fittings. Just like the style, there's a lot of materials available as well. Most common being stainless, plated steel, aluminum, polypropylene, and there are many more available, which depending on what the hose will be and the fitting will be exposed to, we can explore other material options. But the second to the end fitting is the attachment method that's going to be used to attach that fitting to the hose. Peerless, where we can, we really prefer to use crimp ferrules or crimp sleeves. Really give a nice, very secure, permanent attachment method to the hose assembly. Here in the picture on the right, you can see a crimp sleeve, just a basically cylindrical piece of metal. And you also have ferrules, which have this extra lip, like I had mentioned earlier, which will bite into a special groove on the hose fitting and allows for better fitting retention. Make especially a chemical assembly or any high-risk assembly much safer. But we also do get into band clamps and bolted clamps when it comes to, say, a water suction and discharge hose, where you're just getting down and dirty, just trying to pump water from one place to another at low pressures, or just even suction, just taking it out of just a sump pump.
Austin, sorry
Yes.
To interrupt, but one quick question on attachment methods here. What is the most critical or important factor that goes into determining what attachment method is used? Is it more so, end user preference? Is it the fitting type? Is it the hose type? What all goes into the decision making of why we would choose one of these different methods?
Really, it goes into the type of application that this is going to be seen. Like I had mentioned, like for a chemical assembly, we're going to want to use a sleeve or a ferrule, ideally a ferrule, but we're going to want to get the most secure method, since that's the most, if there's a failure, it's the most high risk area for any type of injury due to a hose failure. But if we're just looking at, say, a water suction and discharge hose, where just someone needs something just cheap, down and dirty for the lowest cost possible, where there's a very low potential for failure, and if there is a potential for failure, you don't have a chance for a catastrophic failure or injury, then we might look at band clamps. But really, it depends on the application.
Okay, awesome, thank you. Yeah, I'll let you know if there's anything else on that.
All right, sounds good. And then finally, we'll move into delivery, which basically is how quickly do you need it? Is it something you want to pick up same day, or is it something that it's just you're going to keep on the shelf till it's needed, and there's no rush? Definitely something you'll want to communicate on the front end, as that'll definitely help with fitting and hose selection as well. But in addition to how quickly can be delivered, delivery also refers to any type of other special requirements you may want or need, such as testing, tagging, any type of documentation, whether it be test certs, MTRs, certificate of conformance. That's definitely the best to know on the front end. So once we have that stamped information, what happens next? With that information, you want to provide that information to ideally a NAHAD certified hose fabricator. So how NAHAD plays into this, they will test and certify hose fabricators to make sure that they are building industrial and, well, actually all hose assemblies to their standards to make sure that these hoses are being made safely, correctly, and they base their standards based on industry consensus best practices to ensure the safest, highest quality, and the most reliable hose assemblies. In addition to NAHAD, we also have individual hose manufacturers that provide bulk hose to us, and they will also provide testing of our fabricators and provide certification to ensure that any assembly that's using their hose is going to be made correctly and safely. So touch on this quick, just a few basic, very basic steps in general for building a industrial hose assembly. Start off, so you want to cut the hose to the proper length. That's, we had taken into consideration there is the finished overall length or live length that's going to be needed, as well as the dimensions of the fittings, as you can see here, where you have the cut hose length, but if you're going based on an overall length, you also have to add in extra length of the fittings to determine what cut hose length is needed. Also very important here, you can't just cut this hose to length any way you want. You got to make sure you have a nice straight, clean cut perpendicular to the hose axis, which ensures that when you attach the fitting and you're making your attachment, you really have as much hose in there and as much gripping power as you can to make sure that fitting is retained. Once the hose is cut, you'll put the fitting onto the end of the hose, fitting and the ferrule. This can sometimes require quite a bit of effort, as the hose shank is typically a bit oversized as compared to the hose tube, which allows that hose shank to bite, those serrations to bite into the hose tube to get you as much holding power as possible. Sometimes a bit of lubrication is necessary to do this, but we really want to make sure that when the fitting is being inserted, that we are not damaging the hose shank or the tube of the hose, and you don't want to make any type of modification to the fitting to make it fit any better. These fittings and the hoses are specifically designed and shaped to provide a best holding power that they possibly can. And once again, we'll make sure the fitting is installed to the proper depth. And that just makes sure you have as much of the hose shank been into as much of the hose tube as you possibly can. So once we have the fittings on the end of the hose, here, since we're talking about crimping, got a little video about our crimping process. So what's done here is the outside diameter of the hose is measured. Although hoses do have an outside diameter spec that they are built to, we do see quite a bit of variation between batches of hose, as well as even differences in outside diameter from one end to the other of the same length of hose. So at each end, our fabricator, he'll measure the outside the diameter of the hose. This helps to determine the proper crimp sleeve or crimp ferrule that needs to be used, as well as it helps them calculate the proper diameter that the sleeve or ferrule needs to be crimped down to, which the crimping process is what you'll see here in this video. So you have the dies that come down, grip the ferrule down to the specified diameter, holds it for 5 seconds, and then releases, and we have ourselves a crimped hose. To ensure that it's crimped properly, we'll take a calibrated set of calipers and take 3 different measurements around the finished crimp to make sure that it's actually crimped to the specification that we need and that we want. From there, well, even though the crimp is good, it doesn't necessarily mean that the fitting is properly retained. So to test that, we'll use a standard hydrostatic test. And what this involves is filling the assembly filled with water and pressurizing it to 1.5 times the rated working pressure of the assembly. Once again, that's the pressure of the assembly, not just the bulk hose. And we'll hold that for 5 minutes, during which time the hose will be observed and inspected for any signs of leakage, deformation, or any type of slippage of the couplings. A little bit about this process here, as this is an actual picture of a hose we're testing in our industrial hose shop tank. At the bottom of the image, this is the inlet of the hose. We have water being sent in from the bottom of the hose. And then at the far end, this tank is actually at an angle, so that the top end is slightly elevated as compared to the bottom end. So what that does is, as we're filling this hose with water from the bottom, it's evacuating all the air, pushing all the air out of this assembly. And the reason for that is, when we test using just water, a non-compressible fluid, if there is a failure, any type of fitting, if a fitting blows off, as soon as the pressure is relieved, any energy that is in that hose is automatically relieved, as opposed to if there is any air left in that assembly when we pressurize it and there was a failure, the amount of energy that the compressed fluids, that compressed air can hold, would cause this hose to whip around, could send a fitting flying around the room. So very, very important that we get all air out and we make sure we test with only water. So once we have the hose tested, we make sure everything works. The fitting is securely fastened. We can get into some more of the whatever documentation or traceability requirements there are. From the most simple of just providing a certificate saying this hose has been tested to this pressure for this long, or even just a C of C. And we can also provide MTRs for end fittings if those are required as well. With our ERP system, we also have the ability to really maximize the amount of traceability possible in the case of any type of failure or issue with a hose assembly. We have a video here of our etching machine. In this video, you can see we have in this case a metal hose, but we are etching a ferrule with a unique serial number. So if there's ever an issue with this specific hose assembly, with our ERP system, we have the ability to plug in this serial number, and it will take us into our system to see what internal job this was this was built on. It'll show labor transactions, so we can see who performed the different operations, when they performed those operations. And we also have lot tracking abilities. So from that job, we can see what batch of hose the hose was pulled from, so we can even go back to our manufacturers and perform quality control back to even our manufacturer's level. So as a standard, we will etch hoses with certain information such as the date, serial number, other identifying information such as the max working pressure. But this is customizable, so if there's anything you'd want to have etched on a ferrule, whether it be for traceability or even just for identification purposes, just let us know. We can put almost just about anything onto either a ferrule or a fitting. So once you have your hose assembly. To really maximize its life, you want to make sure it's properly stored. As a basic rule of thumb, when it's not being used, if you can, you'll want to keep it indoors in a climate-controlled facility. But obviously, that's not always possible or feasible. So really, you'll want to really try to limit any type of exposure to humidity, temperature extremes, sunlight, overbending, or just about anything that could wear or damage a hose while it's not being used. And even once a hose has been used and it's going to be put back into storage, good idea to flush it, drain it, keep it clean and dry, and keep it off of the ground. These tips will really help when a hose is not in use and it's in storage. Really get the maximum lifespan you can out of it. So next we'll go into just a little bit about proper installation and handling. Some of the common issues we see when people are having hose issues tends to be overbending, especially near fittings. You can see this hose up in the top right corner being bent way past its minimum bend radius, and that's going to cause damage to the tube, the reinforcement. So it's really going to almost immediately decrease that pressure carrying capability of that hose. You're probably going to pretty soon, especially if there's continuous flexing over the bend radius, you'll start to see a leak or cracking or any type of failure really start to develop right in this area. As I had mentioned before in that short video, we want to avoid any type of twisting of a hose assembly. Hose assemblies really aren't made to handle torsional forces. You'll really want to get a swivel in there. But you want to make sure twisting is avoided both in use as well as during installation. And you'll also want to make sure that there's no potential for external abrasion to wear through the cover, eventually the reinforcement, the tube of the hose. So there's more tips and that we can go through, but these are really the most common that we see. And the common solutions for these are hose supports or saddles, which down this picture down here. One important note here too is that these are more of a hose saddle than a sling. And what this increased surface area of the saddle does is limit the amount of force and abrasion that the hose will experience during use. So you have a much larger surface area holding up the hose as opposed to just a rope or a cable, which could easily wear into through the cover of the hose. Hose reels are another common method of even storage and handling, but make sure you're not overbending the hose. It also keeps it out of harm's way when it's not in use. We did touch on swivel joints a couple times, but those help to relieve any type of torsional stress a hose may see. And a protective cover, whether it be hard plastic or even just a PVC cover, that can help protect from abrasion or any type of external damage. So due to the unique nature and just the sheer number of variables involved with any hose application, it's extremely difficult, if not impossible, to predict an accurate lifespan for an assembly. So it's extremely important to have an inspection or maintenance plan put into place. And the easiest thing to do is just do a visual inspection of your hoses. It's recommended that a visual inspection be done at least once a day or before each shift, start to make sure you're looking for any type of either external abrasion. Over here you can see that these metal support wires are already poking out of the cover, and at the bottom here we should see that there's some bubbling going on of the cover, which is a sign that the media is somehow getting between the hose tube and the hose cover, which means there's some sort of leak going on internally that's definitely going to cause further issues. Visual inspection, nothing is seen there. That's a good idea too, to perform periodic testing of assemblies. This is recommended to do usually about once every 6 months. And this includes performing typically a hydrostatic test, much like I talked about earlier, just to make sure that there's no weak points that have formed in the hose, and just make sure that the fitting still has good retention onto the hose. It's better to find a hose assembly failure during a hydrostatic test than it is in a chemical application, I'd say. And then, as a rule of thumb, when in doubt, remove the hose from service. Definitely in the world of industrial hose, better safe than sorry. Next, we have some common failure modes that we've seen when we are dealing with industrial hose failures. Number one is improper application. So that could be a hose being put into a system where the pressure is too high for the hose. And that's what we're seeing here is there's a burst of the tube, and the burst made its way through the reinforcement and the cover of the hose. So this type of hole is pretty typical of an overpressurization failure. Another example of temperature. Don't really see too many hoses melting, but and when we're talking about the pressure derating for elevated temperatures, sometimes it's something that people don't think of. So once again, make sure that temperature is where it needs to be, as well as just speccing out a hose for a media where the media is not compatible with the hose tube. Just because it's a rubber hose doesn't mean all rubber chemical hoses are going to be compatible with the same materials. So we really want to make sure we get as much information about that media as so that we can specify the proper hose tube. We also see failures due to improper assembly and installation. So that could be due to incorrect fitting for the application. For example, you don't want to use cam and groove fittings with any type of compressible gas. That could lead to easily a fitting detachment. But it's also you can see failure due to poor routing, which is a fancy word for overbending, which is what we see down here in the bottom right. This is a fitting that was a hose that was bent too severely right at the end fitting. And you can see it just cracked the hose and the tube and forced the reinforcement right out of the hose. So in this case, it might be a good idea to either reconfigure piping or consider a bend restrictor. But we really want to avoid any type of overbending during installation. And then similar, once again, to the video we showed, we do see a lot of damage that's caused to hoses based on external abrasion or corrosion. We could have a hose where the tube is rated for a certain chemical, but the environment may have some of the chemical in it that the cover is being exposed to, which could end up eating through the cover and the reinforcement, really damaging the hose and causing a failure. So now we're bouncing back to Greg's story that he had mentioned earlier about this hose failure. So once we got the pictures and really kind of got the story of what happened, few different solutions and procedures we put into place. First of which, we used a crimp ferrule as opposed to a sleeve. That lip on the ferrule that the sleeve doesn't have really gave us much more gripping force onto the fitting, which really, right then and there, as soon as we used a ferrule, really limited the potential for a failure. But while doing the crimping of the crimp ferrule, we made sure, once again, that we're crimping the hose using to a correct crimp spec provided by the hose manufacturer, hose and fitting manufacturer. Once again, checking that with a calibrated calipers to make sure what the machine says we're crimping it to is what it's actually being crimped to. As well as we're performing pressure testing 1.5 times of the assembly before shipping it. Each of these hoses we now provide is etched with a serial number on the ferrule. So in the case that another failure arises, which we hope is a very, very small chance, and hope it never happens, but we can trace the hose, the fittings, and the ferrules back to a certain fabricator and also individual manufacturers, so we can do our due diligence in determining a root cause of failure. So, brings us to the end here, but you probably found by some of our stories, the consequences of hose failures can be serious. Not just, I mean, most importantly, there's the potential for human injury, which you never want to see happen, but also there's time loss, accidents, environmental consequences. But one of the main takeaways we want you to have from this is that that when you spec in an inexpensive hose, you're just looking for whatever hose is the cheapest, you're using this hose to connect much more expensive components of a working system. And really, you're going to want to purchase, inspect, and maintain the hoses, the fittings, and the clamps with the same care, if not more care, than you would for sensors, nozzles, and pumps to prevent any type of failure and accident.
All right, Austin, so there is one question that I'm going to ask you shortly, but before I do that, I just want to mention one thing that I meant to cover when I was giving an overview of the controls. There is also a handout section where you can expand, and you'll see a link to a PDF that was produced by NAHAD that includes the stamped form that Austin showed you earlier. And again, it elaborates a little bit more on each of the steps and just some additional reference information for you to have and put in your arsenal to keep in mind while you're specifying hoses and, you know, really considering, like Austin did a great job of describing, all the critical factors that go into making the decision of creating the proper hose system. So please, you know, take a look at that handout and download it and keep it with you. But Austin, a question that came in was related to a slide you talked about a couple of slides ago, where you mentioned improper fittings used for applications, and you listed an example of a camera group fitting not being compatible with compressed gas. Could you maybe elaborate more on that, like that specific situation and why camera group fitting isn't compatible or appropriate for that service?
Sure. When it comes to cam and groove fittings, as they're called, they're even referred to as quick connect fittings, meaning that they can be connected and disconnected quite quickly. So on the same kind of subject as when we're talking about the hydrostatic test, when you're dealing with a compressed gas or a compressed fluid, if that fitting comes undone, which is very easy to come undone just by its design, you have the potential just to have a huge amount of energy released all at once and over a period of time. So you'll have like a hose whipping around, say if you're using it for compressed gas, if you've ever seen an air hose have a fitting blow off. You'll have that hose whipping around until someone's able to cut the pressure to it. But on the side, when you're using a non-compressible fluid, there will be a release of energy, but it'll be very, very sudden and instantaneous, and all the energy will be dissipated right away. So while you might get a little jolt, you won't have the same amount of catastrophe that you might with a compressed gas. And I guess to sum that up, it's all, you don't want to use a cam and groove fitting just because they are so easy to connect and disconnect when it comes to a compressed gas situation.
Right. Okay. Perfect. Thanks for the explanation. There's no more questions currently in the queue right now. I'll see if there's any follow-up on that, and possibly might get some more answers to the application outside of the webinar. So great job, Austin. And I think, Kevin, maybe you're going to get us wrapped up here.
Yep. Thanks, Dan. Thank you, Austin, very much. A lot of very, very helpful information. And really, I just want to talk just for a second about this concept where people meet pipe. I mean, naturally, it's a dangerous place to be. We take it pretty seriously. Again, a lot of our customers rely on us every day for some pretty critical components that need to do what they're intended to do. So it's our responsibility to make sure that everyone walks through our door, leaves safely. And I know you all feel the same way. So if there's anything that we would leave you with is really when you're choosing a fabricator, naturally we'd love it to be us, but we know it won't always be us. Do make sure that you know their background, and NAHAD is a great place to start. If they're a member of NAHAD, generally they're getting tested, they're getting reviewed, they're having their employees go through the testing. It's a great place to start. So please, we stress that. And again, we're here for any and all. As far as the certificate of completion, if you would like one today, just let us know when you do get the survey at the conclusion of this. Let us know you'd like a certificate of completion. Next week, valve actuation 101. So J-Flow Controls will be joining us once again to talk about really quarter turn actuation, and we are looking forward to that. So with that, I do hope you enjoyed today. We did go a little bit over. We apologize for that, but not everyone talks again as fast as I do, and that's probably a good thing. So have a great week, and we will see you next week. Bye now.